looking at applications of Cramer's rule in ISLM model. First looked at how we can use the Cramer's rule for solving equilibrium values of income and interest rate. Then we talked about that another application of Cramer's rule is that we can use it in the ISLM model to determine how our endogenous variables change due to changes in exogenous variables and parameters. For this, we said the first step is that you totally differentiate the ISLM model, where instead of looking at levels like y, you want to look at changes dy. So we totally differentiated ISLM model, focusing on changes instead of levels, and we said this gave us a new equation system where we had two new endogenous variables. Initially, endogenous variables were I and y, but now it's their differentials. And similarly, we said we have new exogenous variables, which are the differentials of our original exogenous variables. Right, so the first step was to totally differentiate the ISLM model to focus on changes rather than levels. And then we said obviously you rearrange it so that you have endogenous variables, i.e. the differentials of y and I on the right hand side, and you have differentials of exogenous variables and intercept parameters on the right hand side of each equation. So step one, totally differentiate the ISLM model, focusing on changes in certain levels. Step two is rearrange it so that you have endogenous variables on the left hand side and differentials of exogenous variables and parameters on the right hand side of each equation. And then we talked about step three was you write the model in matrix form. Ax is equal to CD. But X was your column vector of endogenous variables, in this case dy and di. A was the coefficient matrix. In D we said we'll just put the in D we said D is supposed to be a column vector of differentials of exogenous variables and intercept parameters, and here we said we'll only put the differentials of those exogenous variables and intercept parameters that we're interested in changing and seeing the impact of this change on on the endogenous variables, right? So here D will only, so in D, we have the option that we can only put differentials of those exogenous variables and intercept parameters that we're interested. We don't have to put all differentials that are on the right hand side in this, only the ones that we are interested in. And C is going to be the coefficient matrix, which is going to include the coefficients of those differentials of exogenous variables and intercept parameters. In this case, we are only interested in changes in government spending and real money supply. So in column D, we only included the differentials of G and of real money supply, and then C included the coefficients. We don't have to add every possible differential that is on the right hand side in D, right? We don't have to add DC naught, DT, DB naught, DD naught if we're not interested in them. We were only interested in DG and DM by P, so that's what we only put in D. So here we can only put in what we are interested in, right? So now that we have done the first three steps, right, where we have totally differentiated ISLM model focusing on changes instead of levels, then we rearranged it and then we wrote it in matrix form Ax is equal to CD. Now finally we're ready to apply Cramer's rule to find the multipliers. So the first thing that you want to compute is the impact of change in G on equilibrium Y using Cramer's rule. Now for this we see that dy is in the vector of endogenous variables at first position, and dg is in the vector of our exogenous variables at first position, right? Because now we know our new endogenous variables are our differentials of our endogenous variables, and our new exogenous variables are differentials of our exogenous variables, right? So dy is in the vector of endogenous variables at first position, dg is in the vector of exogenous variables at first position. So what we're going to do is, since dy is in the vector of endogenous variables at first position, we will replace the first column in the coefficient matrix of endogenous variables, i.e. the first column in matrix A, which corresponds to dy because it's in the first position in the vector of endogenous variables, with the first column in the coefficient matrix of endogenous variables corresponding to dg. So what we're doing is, because dy is in the first position in the vector of endogenous variables, what we're going to do is we're going to replace the first column in this coefficient matrix of endogenous variables with the column corresponding to dg over here, right? So basically replace the column corresponding to dy in the coefficient matrix with the column corresponding to dg in the coefficient matrix of exogenous variables, right? Then we calculate the determinant of the changed coefficient matrix and divide by the determinant of the unchanged coefficient matrix of endogenous variables. Here, we're talking about unchanged coefficient matrix of endogenous variables, IA. But basically what you're doing is, because here the first column corresponds to dy, since it appears in the first position in this vector of endogenous variables, we will replace the first column corresponding to this with the column corresponding to dg here. So here the column corresponding to dg is 1, 0, the column corresponding to dy is here. So we replace the column corresponding to dg 1, 0 with the column corresponding to dy here. And then we'll compute the determinant of this matrix. We know for any 2 by 2 matrix, the way we compute its determinant is we cross multiply and then subtract. So we multiply 1 with minus d2, and then we subtract from the 0 times b2. And then here in the denominator, we have the determinant of the unchanged coefficient matrix of endogenous variables. right? So we just take this determinant as well. We cross multiply and then take the difference. So it's 1 minus C1 minus B1 times minus D2 minus B2 times D1. And then we just simplify this a bit. Right, so in this way we can calculate the impact of change in G on equilibrium value Y. What if I want to find the impact of change in real money supply on equilibrium value Y using Cramer's rule? So again, dy, because we're interested in change in equilibrium value Y due to change in real money supply. So dy is in the vector of endogenous variables at first position. But so the first column corresponds to this over here, in the coefficient matrix of endogenous variables. dm by p is in the vector of exogenous variables at second position, so the second column corresponds to this. So what we're going to do is, we're going to replace the first column corresponding to dy here with the second column corresponding to dm by p here. So now I have this changed coefficient matrix where now the first column corresponding to dy, because dy appears in the first position over here, is replaced with the second column corresponding to dm by p here, because dm by p appears in the second position here. So now I replace this column corresponding to dm by p 0 1 with the column corresponding to dy, which is this, right? So here I have 0 1 and then b2 minus d2, and the denominator is still the unchanged coefficient matrix of our endogenous variables, this, right? This determinant that we already calculated. Again, this we can calculate it by cross multiplying and taking the difference. So 0 times minus d2 minus b2 times 1, and then you just simplify this a bit. Now, if you wanted to calculate the impact of change in G on equilibrium I using Cramer's rule, first we looked at how changes in G and real money supply affect equilibrium I. What if you're interested in how changes in G and real money supply affect equilibrium I? So now we know DI is in the vector of endogenous variables at second position, right? So the second column corresponds to this over here. And DG is in the vector of exogenous variables at first position, so the first column corresponds to here. So what we're going to do is we're going to replace the column corresponding to DI, which is this, with the column corresponding to DG, which is this, right? So then what we're going to have is then di by dg is just going to be the determinant of this changed coefficient matrix, where we're replacing the second column corresponding to di here with the first column corresponding to dg here. So then this would become 1 minus c1 minus b1 d1 and 1 0, right? And then the denominator we have again the determinant of this coefficient matrix of endogenous variables, and again to take this determinant you cross multiply, take the difference. So it becomes 1 minus c1 minus b1 times 0 minus 1 d1, and then you can simplify this a bit. So let's do the last over here, which is that you want to compute the impact of change in real money supply on equilibrium value phi using Cramer's rule. Now we know again di is in the vector of endogenous variables at second position, and dm by p is in the vector of exogenous variables at second position. So we replace the column corresponding to di here with the column corresponding to dm by p here, right? So this column gets replaced with the column corresponding to dm by p, right? So then I write this, so then di by dm by p is just going to be this change coefficient matrix, where we're replacing the column corresponding to di with the column corresponding to dm by p. And we divide it by the determinant of the unchanged coefficient matrix of our endogenous variables. And then again, this determinant is simple. You cross multiply 1 minus c1 minus b1 times 1 minus d1 0, and then you just simplify. So when you want to use Cramer's rule to find your multipliers, you don't need to find equilibrium values of y and I like we discussed in the earlier part. You know, you can find these multipliers without having to find what the equilibrium values themselves are, right? The first step is totally differentiate ISLM model, focusing on levels instead of changes, focusing on changes instead of levels, and then you rearrange it to rearrange it. Then you rearrange your equations, and then what you do is you write it in matrix form: ax is equal to cd, then just find your multipliers. Like if, for instance, I'm interested in looking at changes in equilibrium values of I, so I see di is in the second vector, is in the second position of this vector of endogenous variables. So if I'm interested in its multiply with respect to g, so I'll replace the second column over here, which corresponds to di, with the first column that corresponds to dg here. If I'm interested in its multiplier with respect to changes in real money supply, then I'll replace the second column corresponding to di with the column corresponding to dm by p here, right? And then obviously we take the determinant of this change coefficient matrix, divide by the determinant of the unchanged coefficient matrix. And obviously if we're interested in multipliers of dy, we know dy occurs in the first position of endogenous variables here. So if I'm interested in multiply with respect to g, I'll replace the first column corresponding to dy with the column corresponding to dg. If I'm interested in the multiplier of y with respect to changes in real money supply, then I'll replace the first column corresponding to dy with the column corresponding, second column corresponding here to dm by p, right? And then we take the determinant of this change coefficient matrix divided by the determinant of the unchanged coefficient matrix. In this way, we can use Cramer's rule to find multipliers without even having to find equilibrium values of y and I.